Hi, welcome folks. I'm helping with section 9.2 and it's page 453, number 7a. And this is a good one to kind of show an example. So here we have a rational function and we want to write it, figure out the equation of the function below. So when I have a rational function, I essentially have some algebraic expression over another algebraic expression. When I have them in factored form, I actually get the x-intercept, and then I could have like a whole over a vertical asymptote over the whole. Now there can be more than one vertical asymptote, and there can be more than one x-intercept, and there can be more than one whole. So some of these binomial factors would repeat. What's important with the wholes is that they would reduce like this, and so they would be simplified. So looking at this one, my x-intercept is -6, and so the binomial related to that is x plus 6. The whole is at x essentially minus 0, or just x. And then my vertical asymptote is at -2, so the binomial for that is x plus 2. And then because I have a whole, I need to put this factor again. Okay, so just to write this to look a little different, I'll write x plus 6 over x plus 2. And then I have the situation, if I was to state restrictions, x cannot equal 0 or -2. Now 0 is a whole, -2 is a VA, but they're both part of the restrictions. And so if I distribute these into the bracket, I end up with the equation y equals x squared plus 6x over x squared plus 2x. And I can keep my restriction, x cannot be 0 or -2. And that should be the equation of the graph of 7a. I just want to talk about this a little bit more. So if I had one that looked like this, when I factored it, I have x minus 3 over x minus 3. And so this reduces to that. So I can't have x equal to 3 or 2, but 3 is going to be a whole in the graph. And then this one is actually my x-intercept. So I'm going to have an x-intercept of -1 for this graph. And I'm going to have a vertical asymptote at x equals 2. So once you get these rational functions factored, you can tell a lot about them. Now you could have more than one x-intercept, you can have more than one whole, and you can have more than one vertical intercept. But the pattern always is the same. Vertical intercepts on the bottom, x-intercepts on top, and wholes will reduce to 1 over 1. So good luck with those. Now I just forgot to mention about this horizontal asymptote that it's at 1. This is just a little bit beyond what we're doing in this course. It turns out if you graph it on Desmos or whatever that you end up with a vertical asymptote of 1, and for a lot of these you will. And that'll only change if you really manipulate the function. So don't worry about the horizontal asymptote for these right now. Just work with it the way I showed you, and good luck.